So example 6, we're going to be converting from pi over 7 radians to degrees. That's one problem. That's like problem 11 on your extra practice worksheet. We're going to convert 75 degrees to radians. That's like problem number 12 on your worksheet. Okay, so here we go. Convert pi over 7 radians to degrees. The fact about radians to degrees that allows you to convert from one to the other is that 180 degrees is equal to pi radians. That is a fact of mathematics that needs to be just as common as 1 foot equals 12 inches. 1,000 meters equals 1 kilometer. It's just a fact of numbers here. So those two things are equivalent measures. Different units, equivalent measures. Okay, when we know different units with equivalent measures, it allows us to change from one unit to the other unit with that fact and multiplying by a unit multiplier. So if I got pi over 7 radians, I'm always going to put the unit I start off with on top over 1. So typically radians is given as a fraction, so put that fraction over 1, that's fine, there's nothing wrong with that. And then the fact that we're going to use is that 180 degrees equals pi radians. Now when we use unit multipliers, if you recall from other conversions we've done in other classes, the unit of radians lives in the numerator of this fraction. I need the same unit to end up in the denominator of this fraction using the fact in this equality here. So if I'm going to put pi radians in the denominator, I'm going to put 180 degrees in the numerator. And usually when I'm doing unit conversion, instead of putting the degree symbol, I'm going to put DEG for degrees. At the end, when I write my answer, I'll probably put the degree symbol. All right? But the whole idea of unit conversion here using unit multipliers is we use a fact of equality to create this fraction here. We get the unit on top to match the unit on the bottom, so those units will cancel, leaving us the unit we want to have, which is degrees. And we just get these numbers here in the process. Now, if the radian measure is expressed as a pi number such as this, pi over 7, this pi is the same as that pi, so they actually cancel. This actually becomes 1/7. So in essence, all I got to do to get the answer is multiply 1/7 times 180. So if I type in my calculator 1/7 times 180. You can also do 1 times 180 divided by 7. It really doesn't matter where you put the divided by 7 in your work. Go a couple decimal places. If they don't specify a couple decimal places, it's just fine. So 25.71 degrees is what we have here. So 25.71 degrees is equivalent to pi over 7 radians. They mean the same thing.
How do we divide them to multiply them?
Well, 1/7 is a fraction, so a fraction is a multiplier and a divider. So top number, bottom number is a division. Anytime you want to enter a fraction, the divided by creates that fraction look.
So you just do 1/7 divided by?
1/7 times 180.
Oh,
right?
okay.
Because everything's on top, right? So it's this times this.
And then you divide it by?
And you divide by pi if you hadn't already canceled it out, right? So if I hadn't canceled pi, so I could have also done this. I could have done pi divided by 7 times 180 divided by pi. Same answer, right? So if I cancel the pi's beforehand, that's fine. If I just leave pi in there, punch it all in my calculator, that's fine too.
But to get 25.71, what did you do?
I typed in 1/7, which is 1 divided by 7,
Yeah.
times 180.
Okay.
Yep. Yep. So when you get to this form here, anything on top is a multiplier, anything on the bottom is a divider, but a fraction has to be typed as a number divided by a number. So 1/7 is a fraction. So if you have to enter a fraction, that division happens there as well. Other than that, if you just, any numbers on the bottom will be divided. All right? So if I'm converting from 75 degrees to radians, same idea, but now we're going the other direction. So again, it's a conversion problem, so I'm going to write 75 degrees symbol. I'm going to write 75 DEG. Put that over 1. All right, and now I want to multiply by this fact, but again, I have to look and see what I have for units. Currently, the unit of degrees is in the numerator. I'm multiplying by a fraction here. I want to make sure the unit of degrees ends up in the denominator as well, and that's right here. So on this one, I'm going to put 180 degrees on the bottom. And I'm going to put pi radians in the numerator. So sometimes it's 180 over pi, sometimes it's pi over 180. What we're trying to make happen establishes how we're going to do that. So if I'm starting off with radians, I want the radians on the bottom, I want degrees on top. If I'm starting out with degrees, I want degrees on the bottom, radians on top. So it flips that over, using the same fact both times, just a matter of which one goes on top, which one goes on bottom. Just as before, the unit of degrees cancels degrees, the unit we don't want cancels, we're left with radians. Now, depending on how the book asks for the answers, or if I ask for the answers, whatever, if I just say write the answer in terms of pi, I want to reduce this fraction, leave a pi attached to the number. If it says round to the nearest whatever unit, then punch it in as you see it. This times this divided by that. So let's start with the pi possibility. If I got pi possibility here, it's just going to be 75 times pi over 180. Right, this times this over this, so I write it as a fractional structure.
You don't need that, radians.
Oh, yeah, radians. Really, the unit of radians doesn't have to be written, but just for the sake of just really reinforcing, that's what we did. Putting it down doesn't hurt, all right?
So it doesn't need to be put next to pi.
What's that?
It doesn't need to be on the numerator.
Just that radians, it can be on the, it can be either in front or in the numerator, either way. I usually write it off to the side like that, okay? So, what I want to do now for this fraction answer is I always want the fraction reduced to lowest term. So that those numbers there, 75 and 180, is what I would reduce at this point. So the fact that both those numbers divide by 5 for sure, because they end in 5 and 0, I would do that first. So 75 divided by 5 is 15. 180 divided by 5 is 36. Okay. And 15 and 36 both divide by 3 evenly, so I divide one more time. So 15 divided by 3 is 5, 36 divided by 3 is 12. So altogether, the simplest pi answer for this is going to be 5 pi over 12 radians. That is the correct answer, exact correct answer in terms of pi. So if they actually use the word exact in the problem, they want an answer looking like that. If they don't specify exact or approximate, then you can give me either that answer or the approximate answer using your calculator. So if I punch in my calculator, 5 times pi divided by 12. Again, just I'm entering this fraction. This times this divided by that equals, spits out 1.31 radians. Both answers are correct, but the 5 pi over 12 is exactly correct. 1.31 radians is approximately correct. The 5 pi over 12 is a better answer if I'm using it in math, but both answers will get me pretty close to the right answer. The approximate answer would give me just a little bit more error. So it's just a matter of how accurate you want to be with your answer. But again, they're both right. And again, it's just a unit conversion problem at heart. So use your 180 degrees equals pi radians correctly, and then just enter it properly in your calculator, hit equals, and it'll spit out the right answer for you.